Okay, in this video we'll be starting off on some trigonometry. Now, trigonometry starts by working with a very specific type of shape, a right-angled triangle. And the goal is to use one of the other angles to explore the relationships between the lengths of the three sides. And this might seem like a really specific shape, but it's actually a really powerful tool. People like surveyors can measure the height of tall buildings and stuff without climbing anything. You can just sort of measure a distance along the ground first, and then there are tools to measure angles going up and down, and this information can be combined to get a height using measurements that are purely made from ground level. Sometimes you might not even need to physically see a right-angled triangle. Right? These shapes have a tendency to sort of just appear when you're solving physical problems, right? I've personally used the maths in this topic to help people with their art and woodwork projects and things like that. But more than this, if you take the study of trigonometry further, you find it does way more than just right-angled triangles. For example, waves like this describe things like sound and light and radiation, and in fact just about everything in our universe to some extent. And a really cool thing about waves, even this super weird bumpy looking one, is that they can all be broken up into these pure non-bumpy waves. And it just so happens that behind all of these perfect waves, which again are like the building blocks of every other wave you could possibly draw, hiding behind all of these waves are, in fact, well, just a bunch of changing right-angled triangles spinning around a circle. Okay, but let's come back to Earth a bit and start this from the beginning. Let's take a right-angled triangle here with, say, a 30-degree angle in it. Again, the idea is to be able to use this angle to compare side lengths. And note we say compare because clearly just knowing these yellow angles here tells us nothing about the actual size of the triangle. The lengths of those sides are still unknown. But it does tell us how they compare to each other. So for example, for every right-angled triangle with a 30-degree angle like this, it's always true that if we compare the blue side with the pink side, the blue one is always exactly half the length of the pink one. And clearly if we increase the angle, it doesn't stay that way. So now for this 65-degree angle, if we now look at the blue side, and compare it with the pink side, it's clearly not just half, it works out to be somewhere around 90% of the pink side now. And now we don't just have to compare those sides, we could also compare the green with the pink, say, and find that, of course, at this angle, it's a lot shorter than the others, so it takes up only about 42% of the pink one. And really the details of trigonometry at this level are just working with these comparisons, essentially these percentages, but more exact than that, and using those things to figure out lengths and angles and stuff like that. Okay, so let's come back to this little 30-degree angle, and we'll now dive into some specifics. The first thing we need to do is have a way to identify which sides we're actually talking about. Okay, can't just use colors all the time. Now, you've surely seen Pythagoras, and when we did that, we gave a name to that longest pink side, the one opposite the right angle. And we called it the hypotenuse. Okay, so thankfully, that name doesn't change. But now we have the blue and green sides, and we need to get a bit more precise with them. They're the ones that matter to the 30-degree angle. Okay, what we do is pretend we're standing at that 30-degree angle, and we shoot across the triangle like this, to the blue side. And because this blue side is on the other end of the triangle to the angle we're using, we call it the opposite. It's physically opposite the 30-degree angle we're using. And finally, the green side we call the adjacent. That word just means it's next to the 30-degree angle. And I guess so is the pink side, but he already had a name, so whatever. So now we know what to call these sides. We have 3 machines that are used to make these comparisons between those side lengths. The machines are called sine, cosine, and tangent, or we would just say sine, cos, tan for short. Now, I'm calling them machines, and notice I've drawn brackets next to them. In fact, if you get a calculator and you just hit sine, cos, or tan, you'll see that it pretty much always draws a bracket for you straight away, and that's because these guys are not numbers. They are these machines that expect you to feed them a number. And in particular, they expect you to feed them an angle. So in our case, this 30-degree angle here. So you feed them an angle, then their job is to give you back a fraction that compares side lengths. So the sine machine, the first one, is actually built to compare the opposite side with the hypotenuse. And so they go in the fraction in that order. We saw before that for a 30-degree angle, it's actually exactly 0.5. The opposite side is exactly half the length of the hypotenuse. The next one, the cos machine, that one's built to compare the adjacent side with the hypotenuse. So they go in the fraction in that order as well. This happens to be about 0.87, so for this triangle, the adjacent side is about 87% of the length of the hypotenuse. And finally, the tan machine is built to compare the opposite side with the adjacent. And so they go in the fraction in that order. This happens to be about 0.58, meaning in this triangle, that opposite side is about 58% of the length of the adjacent. And so those are our three machines, sine, cos, and tan. And remember, they're not numbers. They're these machines that you need to feed an angle into. And whatever that angle is, the machines each have a different job. They tell you a fraction that compares different pairs of sides. Sine's job is to compare opposite with hypotenuse, so that's the fraction he gives you. Cosine's job is to compare adjacent with hypotenuse, so he gives you that fraction. And tangent's job is to compare opposite with adjacent, so that's the fraction he gives you. That's where we'll stop for now, but in the next few videos, we'll use these machines and fractions and stuff to actually calculate some lengths and angles. So see you then. Thanks.